This question is from JNU 2016 MA Economic Entrance Exam. It's from CIS, and in this question, we have to determine the absolute minimum for a given function gx within its range from -4 to 2. Now, there is something difference between absolute minimum and minimum. To consider this type of case, we first have to draw a graph to understood this concept. So this is our xy plane and this is our origin, and if our graph look like something this, within range of a to b, so we just configure a graph which is from a to b, and this graph is something like this. Then we can easily find out the minimum point for the graph is at point, say, z. We can easily say that at the point j there is a minimum point exist for this function. But if we consider the point a, we can easily find out that at a also a minimum point exists which is more minimum than point z. So if we just consider two different minimum, this at the point a we find a minimum which is known as absolute minimum, because in the whole range a to b this is the most minimum point. And at point z we also find a minimum, but this is not the absolute minimum, this is local minimum. If we consider the nearest point of z, some say right hand side or left hand side, then z is minimum in respect to those points. But if we consider the whole range from a to b, then there is no longer z a minimum point, the minimum point in this case a. So this is the difference between absolute minimum and minimum. And we have to remember that in this question said for absolute minimum, not for minimum. Now let's just start our question. The given function gx is equal to 2x cube plus 3x square minus 12x plus 4. To find out the maximum and minimum, we have to take the derivative first order and second order for the function, and then find out the stationary point or critical point, and then we have to check the stationary point or critical point satisfy our necessary condition for maximum or minimum, in this case minimum. So our second order derivative have to greater than equal to 0 for minimum point. Just for FOC, our first order condition, we have to find out g dash x, which is first order derivative of this function, which is equal to 6x square plus 6x minus 12. We have to equate g dash of x with 0 to get our stationary point, which is equal to 6x square plus 6x minus 12 is equal to 0. And just simplify it, which is equal to x square plus x, and just write out clear, x square plus x minus 2 equal to 0. Just factorize it, and by factorizing, and it's become x plus 2 into x minus 1 equal to 0. Now our two stationary point, x is equal to minus 2 and x is equal to minus 1. So those two are stationary point. To check the second order condition, we have to find out g double dash x, which is equal to 12x plus 6. Now g double dash minus 2, which is equal to minus 24 plus 6, which is equal to minus 18. Now this is less than 0. So at minus 2 there is a maximum point but not minimum, so we just cancel out this minus 2 point. Now we just find out g double dash at point this is not minus 1, this is actually plus 1. So g dash plus 1 is equal to 12 plus 6, which is equal to 18 greater than 0. So we can now clear that at plus 1, mean at one point we have a minimum value. Now what is the minimum value at point 1? So to get the minimum point at 1, we have to put the 1 in our given function. We have to find out g of 1. Now g of 1 is equal to 2 into 1 cube plus 3 1 square minus 12 plus 4, which is equal to 2 plus 3 minus 12 plus 4, which is equal to 4, 3, 7, 9 minus 12, which is equal to minus 3. Now, by just doing this part of this problem, one can say that now it's clear that at the point 1 there is a minimum point, so our correct option is option C. But this is just one side of the picture, because in this case we have to find out the minimum point for the given range. So we have to check also the minus 4 point, because there is a slight possibility that there may be any more minimum point exist at in minus 4 point. By put the value of minus 4 in our given function g of minus 4, which is equal to 2 minus 4 whole cube plus 3 minus 4 whole square minus 12 into minus 4 plus 4. Now just by calculating we get this value is equal to, now you can realize that there is a more minimum point exist at minus 4 point. So minus at 1 point there is a minimum exist which is minus 3, but at minus 4 the value of the function is minus 28. So the absolute minimum for the following function is not 1, this is minus 4. So our correct option, option A.